welcome back to another GCSE Maths lesson in a row. My name is Brown. Today we're diving into solving linear equations. So if ever wondered how to find that mysterious x in an equation, this video will make it crystal clear. So let's get started. Okay, so first things first, we're going to look at some key vocabulary that's going to help us get through this lesson. So, an equation. What's the difference between equation and expression? So a mathematical statement that shows two expressions are equal is an equation. So where we have an equal sign, we know that's an equation. When we have an expression, so if we just have 3x plus 5, we don't know what this expression is equal to. So that by itself is an expression where there is an equal sign and we know what it's equal to, so that becomes an equation. Right, so then next thing, what is a variable? So a variable is an unknown term. So in this example, x is the variable. So it's often represented by a letter that represents an unknown number. That's what a variable is. A coefficient, any number multiplied by a variable, is known as a coefficient. So in this example, 3 is a coefficient. A constant is a fixed value that doesn't change. So 5 in this example and 10 are both constant and their value does not change because it's not multiplied or divided by anything else, by another variable, I mean. Right, and then an inverse operation, as we discussed in the previous lesson, is the opposite mathematical operation used to isolate the variable. So if I want to isolate x, my variable here, which is x, then the first thing I've got to do is I have to subtract 5 from both sides. So the reverse operation of adding 5. And then once I've done that, I'm going to divide it by 3 because the variable is being multiplied by 3 and the opposite operation would be division. Right? Hope that makes sense. We're going to look at more examples. Right. So what are linear equations? So a linear equation is an equation where the variable is raised to a power of 1. So these are the typical example. X plus 3 is equal to 7, 2x minus 5 is equal to 9. Both of these x's are raised to the power of 1. Now, we don't tend to write the power number, the indice number, with linear equations because x to the power of 1 is equal to x. So if there's no number, that just means it's raised to the power of 1. So as long as it's not squared or cubed or to the power of 4 or any other indices, then it's a linear equation. If there's no number next to the x on top of the x, that means it's raised to the power of 1. That is what a linear equation is. So these are the foundation of algebra. So mastering them is the key to solving the more complicated examples. Let's go through some examples and let's go through them step by step. Now, the key to solving algebraic equations and linear equations, to be more specific, is to break it down into multiple steps until you've mastered them, and then you can skip steps or do the steps in your head once you feel confident following the steps. Now, first things first, when solving linear equations, these are the steps we're going to follow. First, we're going to simplify both sides of the equation by combining like terms. What do I mean by like terms? So I have two variables here. I have x and x on the same side of the equation. So I'm going to simplify it by adding them because 2x and then this is plus x. So first I'm going to add these two. That's simplifying them. If you have other terms, that's exactly what you're going to do. We're going to simplify by adding the like terms. So numbers go together and x's go together, or unknowns go together. So this becomes 3x minus 3 is equal to 9. The second step would be get all the terms of the variables on one side of the equation and the constant on the other. In this case, I need to move the 3 to where the 9 is, so I have the constant on the same side as well. But remember, we're going to do the reverse operation, which means we're going to add 3 to both sides. Minus 3 plus 3 gives us 0, so on this side we're left with 3x. On the other side, 9 plus this gives us 12. So the next step would be we need to isolate the variable by performing the inverse operation. So the variable is multiplied by 3. We're going to perform the inverse operation, which is we're going to divide both sides by 3. 3x divided by 3 simplifies to 1x, or in other words, just x. 12 divided by 3 is equal to 4, so x is equal to 4. Right, does that make sense? I hope that it does. Let's keep going with other examples. Similar example to the previous one. So first things first, remember we're going to simplify both sides of the equation. This is as simplified as it gets right now. We have 3x and minus 8x, so be very careful with the signs. 3x minus 8x, so we're subtracting 8x from 3x, leaves us with minus 5x. So when we simplify, we get minus 5x minus 2 is equal to 13. Next step, if you remember, was we're going to get all the variables on one side and all the constant on the same side. So I've got a variable here, I'm going to take the constant to the other. We're going to inverse the operation. So minus 2, the inverse of that would be we're going to add 2 to both sides. We're left with minus 5x is equal to 15. Next, we're going to isolate the variable by performing the inverse operation. So we're going to divide both sides by negative 5, right? So minus 5 divided by minus 5 gives us x minus 5x divided by minus 5 gives us x. 15 divided by minus 5 gives us minus 3. So be very careful with your signs. A positive divided by a negative gives us a negative. So x is equal to minus 3. Let's keep going. Let's look at another example. Now, solving algebra with fractions. Okay, so we have 2x over 3 plus 1 is equal to 5. So remember, what we're going to do is we want to isolate our variable. So first, we're going to move this, then we're going to deal with the 3. The reason why it goes in that order is because 2x, it's only the 2x that is being divided by 3, not the whole thing, right? So we're going to isolate them one by one. So first, inverse operation. We're going to subtract 1 from both sides. That leaves us with 2x over 3 is equal to 4. Then we're going to isolate 2x by doing the inverse. It's being divided by 3, so we're going to multiply both sides by 3. That leaves us with 12 on this side, and these cancel each other out. So we have 2x is equal to 12. Then we're going to divide both sides by 2, and we're left with x is equal to 6. Hope that makes sense. So remember, with fractions, if the whole thing is not divided by 3, the 3 is not what we're moving first. The 1, the constant, is what we're going to deal with first, and then the fraction. If you had something like this over 3, the whole thing is divided by 3. So the first thing we're going to deal with is getting rid of that 3, because it applies to everything on top. But here, the 3 is only associated with the 2x. So we're going to deal with the constant first, and then with the 3. Hope that makes sense. Let's keep going. Okay, an example similar to what I was just discussing in the previous example. So 3w, so our variable in this time, is equal to w. 3w over 4 is equal to 1 over 2. So we got fractions on both sides. We're going to follow the rules of fractions, but the algebra steps of solving algebraic equations doesn't change. So 3w is divided by 4. To do the inverse operation, we're going to multiply both sides by 4. So we have 3w on this side, then we have half. So if I deal with this on the side, half multiplied by 4. Remember, if we have a fraction multiplied by a number, we're going to turn the number into a fraction as well. We do this by giving it a denominator of 1. The reason why we can do that is because we want to have fractions on both sides, and 4 over 1 is the same value as 4. So we're not changing the value of our number, we're just putting it in the format of a fraction. And then when we're multiplying fractions, we're going to multiply across. So 4 times 1 is 4, 2 times 1 is 2, 4 over 2 is equal to 4 divided by 2, which is equal to 2. So we have 3w is equal to 2, and then to isolate the w, we're going to divide both sides by 3. So we're left with w is equal to 2 over 3, and it's perfectly fine to leave your final answer as a fraction. So if we have a fraction like this, where we have 4 over 2, we know the perfect fit. We know that 4 can be divided by 2, and it's going to give us 2. However, 2 divided by 3 is going to give us a decimal, so we don't need to define that and find a decimal number, unless specifically mentioned, give the answer to 2 decimal places or vice versa. We can leave the answer as a fraction, right? Let's keep going. Another example, a more complicated example. This is what a typical GCSE exam question could look like. Now we have 5x plus 4 is equal to 3x plus 16, right? So remember our steps. This is very important that we're going to follow the steps. The first step was we're going to simplify both sides of the equation by combining like terms. I'm going to keep repeating the steps until you get the hang of it and you master them. So we're going to simplify both sides of the equation by combining like terms. We don't have any like terms on the same side of the equation. The next step, for this example, the next step was we're going to get all the terms of the variables on one side and the constant on the other, and that's where we're going to start with this example. So we have x's on both sides and constant numbers on both sides. So we're going to bring the constant, collect the constant on one side, collect the variables on one side. So, okay, inverse operation. So I'm going to bring the x's to the left and take the numbers to the right. Now it doesn't matter which side you're collecting each of them on, as long as the variables are together and the constants are together. Doesn't matter. At the end, you'll get the same answer. So first things first, I'm going to do the reverse operation. So I'm going to subtract 3x from both sides. 3x minus 3x leaves me with 0. So on this side, I just have 16. 5x minus 3x leaves me with 2x plus 4. Now, I have my variables all simplified on one side. However, my constants are not. So I'm going to do the reverse operation one more time. I'm going to subtract 4 from both sides, and I'm left with 2x is equal to 16 minus 4 is equal to 12. And then I'm going to do the reverse operation once more to isolate the variable, divide both sides by 2, and I'm left with x is equal to 6. I feel like a lot of our x's today were equal to 6. But as long as the method makes sense, we're good to go. Right. First things first, I don't know why I have bullet points and numbers there, but just go with me. So here are some common mistakes to watch out for. Forgetting to perform the same operation on both sides. So for example, if we have something like 2x minus 5 is equal to 10. So if I'm doing plus 5 on this side, very, very common that student will go with 2x is equal to 10, and they forget that they meant to add the 5 on this side as well. So whatever happens to one side of the equation will always happen to the other as well. Very common mistake, so watch out for that one. And then dropping negative signs. So remember when we were looking at, I'm going to write down here, when we were looking at 2x is equal to, let's say, minus 10, and then to isolate the variable, we're going to divide both sides by 2. We were looking at something similar to this. X is equal to, a negative divided by a positive is going to give us a negative. So the final answer would be minus 5 and not 5. And it's very common that the student will forget that a negative and a positive gives us a negative, and vice versa. Another thing to look out for in this example, you could get something like minus 2x is equal to minus 10. In this case, we're going to divide both sides by minus 2. So minus 10 divided by minus 2. 2 negatives will give you a positive. So in this case, the answer would be 5, because a negative, minus 10 divided by minus 10 gives us a positive. So it's plus 5. So be careful with your negative signs and carrying them over and when you're dividing them. The third common mistake that I see very common is skipping a step. So remember what I was talking about before. It's okay not to write everything down, the steps, once you've mastered them. But to begin with, I would definitely recommend that you start by going step by step. So the first step is you're going to simplify both sides of the equation. Then you're going to get all the terms with the variables on one side and the constant on the other. Then you're going to isolate the variables by performing the inverse operations. So those are the steps that you must absolutely follow. But when students don't write them down, it's very easy that you skip a step, and the end you get the wrong answer. Right? So be very careful with that. And then that should have a number there, should say number 4, but double check by substituting your solutions back into the original equation. So if you get x is equal to 2, if you have an equation like this, 2x plus 5 is equal to 10, and you found that x is equal to 2, take that value of x, the 2, substitute it back into the equation and see, do you get 10? So I totally made this up. So if I substitute this back into the equation, 2 times 2 gives me 4. 4 plus 5 gives me 9. So that tells me that x is incorrect. So that means I've made a mistake. I'm going to go back and review every step to see where I've made that mistake from. So very, very good way of double checking your answer. Right? Right. So now it's your turn. I have an equation on the board, 4x plus 1 is equal to 2x plus 7. Solve this equation and then leave your answer in the comments. I'll go through them and I'll check them, and we'll leave you a little note. Good luck, let me know how it goes. And that wraps up today's lesson on solving linear equation. If this was helpful, don't forget to please like, subscribe, and share it with your friends. Also hit the notification bell so you don't miss our next video on solving equations with variables on both sides, which we looked at today as well. But we're going to look at some typical GCSE exam questions that have come up in past papers. And we're going to look at a little bit more complex equations on higher papers as well. That's it. So see you next time, and happy studying. Have a lovely day. Bye.